First of all, thank you very much for having me there. Second one, there are like two excuses. First of all, it's a bit of a maiden voyage because this presentation was never told to the people, so let's see how it's working. Second, of course, it's very interesting because today I will call, so I'm really curious how it will work out. Because I will receive a page reviews in the middle of the presentation, probably I'm doing something wrong during my work day. My name is Kirill Kolyaskin. I'm working as a lead engineer in a fintech startup called Newton. Well, essentially I'm a Linux engineer and I'm Red Hat architect in my background. And what I truly believe right now, I truly believe in serverless.com, and I'm working to basically build awesome, cool server. Is it actually working? Yeah. So I'm trying to dedicate my time to ensure that serverless architecture could basically be empowered. And in the company where I'm working, I try to explain to people why we want to do things serverless, what's the advantages and disadvantages of it. And in the spare time, basically, I'm usually drinking wine and crashing my pod. This topic is going to be about how we're doing extreme ownership in U10. And before going to the topic, what is extreme ownership, why it's important, and why certain choices has to be made, it's quite important to explain basically what U10 is, because business requirements and market requirements indeed are kind of pressing you to make certain infrastructure or development choices. So very short, like just to mind this thing, how many of you are technical people, like developers, cloud engineers, testers? Cool enough. And how many of you have anything to do with a bank? Not like having a bank account, but basically working in a financial environment. Cool. So I will try to adjust my story a bit on this, like to ensure that everyone on the same page. It's very easy. Newton is a startup, and we're 100% subsidiary of ABN AMRO Bank. And what our business idea is that we're trying to combine the best of the world. So on one hand, we're taking agility, eagerness to deliver a value, and very deep technical understanding of any technical cool startup. On the other hand, we're taking experience, funding, and expertise of a huge bank and trying to make the best out of it. And what we're doing for living, we're giving the money to entrepreneurs, and we're doing it digitally. So basically, like if you want to have, if you have example by way, and you're going to a bank, first of all, you have to came like physically to a bank with your legs, which is a bit annoying in the 21st century, and then you have to spend some time there, filling out documents, doing some paperwork, and maybe in 2 weeks or 2 months or 3 months, money will hit your account and you will receive your loan. No, because it's really old school way. What we're doing, you go into website, you fill some documents, we're making some calls to KVK, which is that Chamber of Commerce, we're making some checks, and then we have an answer to you. Okay, this is your money, or sorry, work a bit more, you're working on the market only for 6 months, it's way too risky to give you money, we will suggest you to come back in 6 months. So it's very simple flow, really fast, and we're doing everything digitally, including signing. So imagine that one day, big guys from a bank came with like a big box of cash to you and saying like, you have to build a cool startup, you have 7 months. So there are some choices to be made because it's a short term. You're probably thinking, what kind of architecture should I choose? Where do I need to run it? So I'm going to buy a data center, put on my laptop, my AWS account or something like that. On which language should I write it? Because you can do it in COBOL, it will take probably 10,000 years of your life. Or you can do it in PHP, which is way faster, but then I'm not sure if you want to run your core banking in PHP. How in general stuff process, should I rent an office or should I just like do it like GitLab so people can work from home? And then in general, how your team look like. And answer on this question will heavily influence your infrastructure, your CI/CD, and your code base. So this is the answer that we gave 2.5 years ago when we started. We're going to build a monolith. Because right now, like majority, like very often I heard like, monolith is bad because it's big and fat and like, in general not sexy, let's do microservices. But basically if you have one type of business, one type of flow, it's totally right to have monolith, and it's fast to build. And you have 7 months, otherwise, no money for you anymore. We choose to do it in public cloud, and we choose AWS because we're lazy. Like I'm personally very, very lazy. So I don't want to have like my own data center. I don't have money to buy data center in front. I need something on demand because maybe in 6 months the company doesn't exist anymore. It's proof of concept. Plus, I don't want to manage anything. I don't want to change, I don't know, like network cables. I was doing it for 10 years. No, I'm not anymore. And you choose the languages. And it's very easy because you have a front end of JavaScript and you have to build your risk calculation model, which means Java, because everyone who builds a risk calculation model is working in the environment and you're writing Java, or she's writing Java. They might do COBOL, but you don't want COBOL, believe me. And does somebody knows what this awesome symbol means?
Agile.
Okay, like, because I was Googling like how to do agile, so I was like, seriously, like, yeah. So we really believe in agility and we have a short iteration, so we decided, okay, we have 7 months to build something, let's make it fast, let's make it cost, because I don't want like spend half of your life in waterfall. So in 6 months, that's what we had, we came live, and it was very simple, straightforward infrastructure. So we have a front end with essentially S3 bucket with a cloud front in front of it. You deploy through CI/CD pipeline, which is Git was there. Very simple. Using cognitive authorization. I have absolutely awesome service from AWS. Just 2 buttons and you have a user code with authentication, MFA, everything there. We have very simple structured front-end middleware, essentially model written on JavaScript that making calls to all third-party services. It's like sign host for signing, Dutch Chamber of Commerce, banks to basically obtain the transaction data, and have an old school big fat backend on Java that basically calculating risk and say yes or no. Absolutely cool. You run, you're happy, your stakeholders and investors are happy as well, and this is step 1. As a developer, you own the code. It's something very natural. You wrote the code, you own it. But then, of course, guys come into like, well, cool, what about new product? What about new functionality? You prove yourself, you're all good. Let's change something. And you're like, oh my God, now I have a monolith. And guys who live in not monolith, maybe will leave one day, or maybe you already like split the race with them. And it's like, I have to do something. So we have to do ecosystem of microservices. Because it's easy, because you know it's kinda, you have event bus and you have a different part of microservices you're attaching to event bus. If the new service is added, you just attach it. If you don't need it, you remove it, and whole your ecosystem will still work, and it's very easy. So you're like, okay, what am I gonna do? This is our ecosystem of microservices now. And there is quite a gap between how it was before and how it's now. And when you're watching from your one monolith towards this ecosystem microservices, there are some thoughts in your mind. Okay, how I'm going to manage the deployment? I'm going to do Fargate or ECS or Lambda. And essentially, you want to do Lambda because it's easy, because when you do Lambda, it's cheaper. It's concentrating on the business value, not managing your Docker container. It's basically have a very short circle from start writing code to deploy to production through some tests, understand that it's not what you wanted, and you roll it back. How you do CI/CD pipelines? Who is responsible for all the CI/CD pipelines? It's cool if you have a huge Jenkins team, but you're like 15 nerds sitting somewhere in the basement, and you hope to grow one day. So ownership of CI/CD pipeline is something you really have a discussion with your developers. At the end of the day, you bank and have compliance. How to ensure that all these microservices are compliant? Who is going to manage this infrastructure, and how you will test it all? Because when you're doing deployment of one ecosystem, one Lambda ecosystem, you should think about contract testing or maybe integration testing in general. How you're going to organize it all? So answering all the questions one by one. First of all, okay, we want to do Lambda. How we want to deploy it? And you have 4 big players on the market of deployment Lambda to AWS. It was 4 players back then, it's still 4 players now. You start with the CloudFormation, which is essential native tool for AWS. But then you realize it's not so agile to deploy Lambda 3, and it's really difficult for developers because they do need to know CloudFormation. It's not exactly the zone of expertise. So okay, bye-bye CloudFormation. Then you're like, okay, I will do Terraform because our cloud engineer are doing Terraform. But then Terraform itself has a conception of this state file that is difficult to split per project. So it means that everyone kind of deploying all together, creating a lot of dependency, and bye-bye, Terraform. Then you're like, well, AWS guys are so smart, they're cool, they have this basically the deployment for Lambda's framework, really native, really cool. Or you can use open source serverless.com. And you have a very, very long discussion with the developers, and then even longer discussion with the developers, and then you're doing very, very simple calculation. You're just calculating amount of frameworks and models and plugins for serverless.com, and you find that it's like 50 times more than for some, and you say bye-bye some. So we decided to go to serverless.com framework because it used to be the biggest one framework for deploying Lambdas. It still is. Some is developing really fast. Still, I don't expect some being as big as serverless.com for like a couple of years from now, I would say, with all my deep love like AWS. So using serverless.com to do deployment. How many of you ever use serverless.com framework? Okay, so I'm not going to spend a lot. It's cool, right? It's very cool too. So it's giving you YAML file. Everyone could fill that YAML file. You just push it through, and serverless.com framework through basically CloudFormation below it will help you to deploy your Lambda in a very easy way. It will create API gateway or S3 bucket for triggers. It will pull tags for you. It will attach AMRO. So basically, it's allowing developer not only deploy Lambda with code and business logic, but the whole ecosystem around it. What this Lambda needs around it to actually bring some value for client on that day. It's YAML based. It's really like everyone can understand YAML. If I can, everyone can. It's really abstraction on AWS CloudFormation, so nobody expects you to understand a CloudFormation. It's quite difficult. It's create a lot of stuff from you. It supports customer resources, and it supports local invocation, which is super difficult for sometimes to test something remotely, especially if you have a long pipeline, for example, using Jenkins. You deploy and you wait 5 minutes, and then you test and it's not working, and you have to deploy it again. It has a local mocking, so you can run it locally, develop locally. The developers are going to be happy. So, and at this moment, it was like something about like a year and a half ago, we have a separation of infrastructure. So we have stateless infrastructure, which is deploying through serverless.com framework, and basically it's Lambda, AMRO for it, it's some CloudWatch metric that deploying together, it's a step function, and it's SNS in this case, everything that unique for this service, microservice, so it's developer making a mistake, he or she only damaging her service. And if you just remove it all and recreate it, no data is lost, only data in procession. So it's not like you just nuke your database and then like, oh my God, how to recreate it. And all stateful infrastructure was still in the zone of responsibility of infrastructure team. So S3 buckets, DynamoDB, RDS, I still kind of bottleneck because developer, for example, she's deploying her front end with a bunch of lambdas with a step function, and then like, okay, and now I have to wait 2 days when they will deploy database for me because I'm busy. So that is something we wanted to tackle, but well, it's not easy to do. And this is basically a moment when your developers owning your stateless infrastructure. They cannot own all infrastructure yet, but they're already owning something of it, which is huge progress. And then, of course, you start looking towards how we do CI/CD essentially. The core part of our CI/CD is GitLab.com. We're using basically a shared version of it. We're not hosting it yourself because we're lazy. Why you host it by yourself? If you're a small startup, just buy it. And around GitLab, which we're using for many things, but mostly for Git repo and CI/CD, there is ecosystem of tools. So we're using Sonar Cloud, Snyk, and OWASP for security, like kind of proactive security, to ensure that nobody will deploy vulnerability. And we have ecosystem of tools for reactive. So we're using Sentry.io, Datadog, and PagerDuty. From Sentry and Sentry and Datadog, we're piping all metrics, all errors, all exceptions. We're aggregating them there. If there are some alerts, we throw it to PagerDuty, and PagerDuty start calling somebody who isn't called today, like me. And of course, we use a lot of tools from AWS because AWS out of the box giving you a lot of tools for configuration, for monitoring, to ensure that infrastructure that you deployed compliant to your rules, to ensure that your CI/CD is working as expected, to ensure that nobody made a mistake and push public S3 bucket with client data somewhere to prod. And well, we have a bit of shameful, very Python and Bash scripts written by me and some of my colleagues, kind of to stitch it all together. It should all die like 2 years ago, but it's still there and it's slowly dying. And it's, well, you know the story, you know the drill, right? It's like it's there. It will go one day, probably not tomorrow. And we have this idea that basically developers like bringing value to company. Like myself being cloud engineer, basically I'm not bringing a lot of value to company. I'm not making new features for clients. I'm kind of helping developers to bring value, and that's why I'm receiving my salary. So keeping this in mind, we start choosing our CI/CD tools. So GitLab.com is something that really developer-oriented and uses SaaS and DAS from there. Not only Git and CI/CD, but static and dynamic code analysis. And it's really cool because all the security reports there, not given on some dashboard and nobody is opening, or only PO is watching there and then shouting at people. Basically, developers seeing vulnerabilities when they make a merge request on the master, and you can see, oh my god, I probably shouldn't merge it. We use Sneak for dependency scans. Well, we're willing one day to move it towards GitLab.com, but right now the security features for that are not up to our standards. Sneak is really cool tool, so it's integrated in pipeline and saying, this vulnerability is bad, not use it. And what is not shown here, but they have a different graphic, which show not only amount of vulnerabilities, but time to fix it. And this is where very angry CISO guys are watching and saying like, okay, it's okay to introduce vulnerability, but it's not so okay not to fix it for 3 months. Because it's showing you as well how long it takes to fix your problems. And AWS have awesome stuff called IAM permission boundaries to service control. Because when you are deploying your Lambda and you're giving this Lambda IAM role, which essentially allows this Lambda to call on other services, you're giving a lot of trust to people because they trust them and you want to empower them to do their job the best possible way, but you still want to protect people from making mistakes. So you can use SCP IAM boundaries to say, okay, you can make whatever permissions you want, but never, never, never give permission to remove all users because it's bloody not safe. And then, of course, using all these tools, you're coming to who is owning pipelines. And first of all, how GitLab is working. In each repo, there is a YAML file and pipeline describing there. That's really something that empowers developers, so you don't need a separate team to manage it. Everyone can take a look at this YAML file and configure a pipeline. And this is how it started. One pipeline per service owned by DevOps engineer. Because you have 3 services, it's really easy to own it. So if developer needs something, she or he came to you, you fix it, you update something, everyone is good. Your monolith is working. 6 months later, you have like a bunch of microservices and people like staking in a line in front of you. That's like, can you please update there or there or there? Like, oh, I don't have time, come to me tomorrow. And this is a problem, everybody's upset. And you're going to the next level. You're like, whoa, 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 stop queuing in front of my desk. Everyone receive a standard pipeline, like Java boys receive Java pipelines. I don't know, data scientists receive their standard pipelines, and JavaScript receive their own pipeline. If you want to run tests in different places, not my problem, we will do like very, very standard things, one per service type. Well, it's perfectly working for a certain time, but then you have small riots, because people, surprise, surprise, know better than you how to do their pipelines, what they need, and there is all this discussion like, I want changes. I want changes in all my pipelines, in 5 of these pipelines. It's just not scalable. We have hundreds of these pipelines. You're not sleeping at night, you're like, okay, we will do shared pipelines. So you're gonna have like one big pipeline that includes in every other pipeline. You have kind of centralized wrap of pipelines when you're sitting there and changing something, and all downstream pipelines are changing. Well, honestly, it was the worst idea in my life, basically. Because what's happened? First of all, people don't know how their pipelines are working, so they come into you all the time. and they assume that it's your problem because you're owning the bloody pipeline. And the moment when we realize something really, really bad, when one of my engineers received a Slack just a link on a failed job without any comments. And I'm like, what the hell is that? Like, apparently we have to fix it. I'm like, okay, let's have a discussion about it because it's not just working. And then of course it's something really damaging software engineers, their approach and they're willing to do, because they're really afraid you have one shared pipeline that kind of downstream to 15 projects, and somebody changed something for his project and then like 5 other projects failing because the change was okay for one project, not for another. And it was really painful discussion. We said, okay, sorry. Well, it's a mistake, sorry. It's one pipeline per service owned by developer. So what we decided, like, guys, we as a cloud engineers, DevOps guys, cannot know your pipeline. Every developer knows best. So what we're gonna do is say, okay, now it's your pipeline, you will be responsible for it. We will run some internal training, we will give some transaction period when people will learn how to use GitLab CI/CD pipeline, what's possibilities are there, and after that, not cloud engineer, because it's wrong, but developer will own your or his pipeline, which is awesomely working, because no one better than developers know how to deploy their stuff. And work. Continuous integration is deployment now on the plate of developers. But then you have a question of observability, because people are deploying their stuff, and they sometimes don't know how to monitor it. Well, everybody knows how to monitor it, but where to look, what to collect, how collect metrics and logs in most cost-efficient way, especially because what we're doing, we're using Datadog, and Datadog is a great tool with one kind of, characteristic that could be said as a strong or weak points, depends from where you're watching. Datadog doesn't have full text search. So there is no way you can throw like Java stuff, logs in the logs, and then just search this in Kibana. You should think what you're putting in logs, otherwise you will never able to find it, because logs are going in JSON, and Datadog is indexing per key. So if you have to find the value, you should think what you're putting in logs. And well, Datadog is really natively integrated with AWS CloudWatch, and we're piping stuff to the Datadog. And then, of course, we had a very long sessions with the developers to understand what we're willing to log, how we ensure that client data is not leaking to Datadog, and how we ensure that people can find stuff in log. Otherwise, there's no point of it. And separately, because it's a very bad practice from my point of view, and people debugging on logs or monitoring in logs for errors. There are absolutely separate tools like Sentry and other one who doing exception handling. If you have an error, Sentry will know about it, and what this awesome tool as well is doing, it could make an aggregation through services. So if you have like front end that call middleware, that call like third service, fourth, and number 5, in each of these services, on a special moment you have some exceptions, and you have a trace ID, Sentry could understand and merge together, and kinda then in PagerDuty, which is our escalation software, create an incident not for your Gandalf service or backend service number 35, but it's actually like payments are not working or front end is down, something like that, which basically makes a lot of sense for business people. And mostly important, it's managed service, so you don't need to run it, because I don't want to run anything and we're lazy in the time. It's only API-based integration, because we truly believe that the software doesn't have API, we don't want the software, and it's in for the code. So when we deploy a new service, we make sure that Datadog through Terraform already deployed in terms of logging aggregation, in terms of dashboard. The same stuff for PagerDuty. PagerDuty supports Terraform, so when you're doing your deployment of your service, you're creating the service in PagerDuty as well. And if it's not created, we're not allowed to push in production. This is basically how observability is working. So we have a monitoring and logging going to CloudWatch, from CloudWatch to Datadog. Error tracking and distributed tracing through X-Ray, which is native service of AWS to manage distributed tracing of the lambdas, and Sentry to Datadog. And from both of these sexy tools to PagerDuty, so people call at night like bear, wake up, fix your stuff. Apologies. And now, when you have a PagerDuty, there are people in PagerDuty, so you need basically some escalation. Because I do remember, like, it was like infernal story of our developer Marco. We liked him very much. He was the most responsible guy, and he was like in the very first month on call 31 days from 1 month. So he was quite upset. So how escalation is working? This is PagerDuty. For example, you never saw how it's working. This is basically a screenshot from PagerDuty. So there is a triggered alert, and each alert has a service, and service has escalation policy. So something wrong in our GraphQL, we have an incident, it's triggered, and it's assigned to JavaScript policy. So you have a developer, Danny Hook, who is basically on schedule today, so his bad day. Then you have a Guy, who's our lead JavaScript boy, and he's running the show. And then, for example, Danny is really sick or just driving, Guy will pick him up. And then we have a level 2 schedule, basically all tickets in rotation, just to keep people motivated when they're driving and not calling and not able to pick up a call. And then, of course, we have a rotating schedule. So what there are like different things. So first of all, we have a multifunctional, of course, multidisciplinary teams. So we try to do rotation on feature team. Now then, of course, like you can shoot your own leg if you have one JavaScript developer, and it's not his rotation, Java developer cannot really help. So then we decided to do based on, let's say, zone of factors. So we have a JavaScript, we have a Python, we have a Java, we have a cloud engineers, we have a quality engineers, we have the escalation policy, and each service going to the zone of factors of the people. And you have an incident management managed by your developers. But then you're very, very lazy. You're so lazy, it's mean that you don't even want to do Terraform databases. So you start thinking how you can empower developers to actually own all the infrastructure of your service. Because what's happening right now already, you have a Lambda, you have an IAM, you have step function, backend girl or front-end guy could do it already. They're fully empowered. You're like, okay, how to deploy S3 bucket? Well, obviously through Terraform. And it was like, well, we didn't, came with this cool idea. We just stole this idea from AWS. We came to Reinvent, we came to Keynote, and there is like forums like, we're doing building blocks. We're doing building blocks. We're like, fuck, we will do building blocks as well. So what we're doing building blocks. So we have, for example, our Terraform experts, which I pretend to be at least, and our team, we're writing Terraform module for developers. And developers can invoke this Terraform module that's already up to certain high standards, and just pass certain variables there, and ensure that through this model they can easily create DynamoDB or S3 with proper tagging, that encryption is enforced, that policy already in place, that this S3 bucket synchronization with our backup account. So people could actually create infrastructure on their own will with a very high standard without making mistakes. But then, of course, what's difficult, that means that people should not only understand how to write a code in their own language, they should understand how serverless.com framework is working, how Terraform is working, and whatever, and it's quite difficult. So you're trying to give a certain level of abstraction on top of it, and you come with something called Newton Toolbox, which is really a pathetic name. It's a Go-written application that basically allows you to invoke Terraform, serverless.com deployments, certain testing, certain comments to ensure that people could deploy very natively without deep understanding how Terraform is working. And if you take a look, it's like there's like toolbox, SLS deploy, like serverless deploy, taking the stage name, taking the service name, says assume role. It doesn't say which roles I assume. There is already a predefined role for deployment that people can just invoke, and everything going to be all right. And then in GitLab CI/CD, you can see how your stuff is deploying, how it's going from environment to environment, where it's failing, where you can make some, manual steps to ensure that you're only going to production when you want to send it to production. But of course, you don't trust even yourself, because okay, you have a cool toolbox, you have everything predefined. What if you made a mistake? What if everything goes south and you still deploy something uncompliant? We're using AWS config. This is a very cool service from AWS that just invokes a bunch of lambdas and checking, saying your WAF policy, which is Web Application Firewall, is not compliant, so you don't have a firewall in front of your shit. Or your encryption is not compliant. So here's an awesome example. We changed our tagging policy. We introduced certain tags, and people need a lot of time to change it. So we have like 25 uncompliant resources, not actually true, we have like hundreds of them, because tags are not there, are not up to standard, so you have to wait until people will fix it. So like if you're running on AWS, this is what you basically want to take a look. It's a very cheap AWS managed service. It has auto remediation, which we are not using yet because it's a bit dangerous. But what you can say, if somebody deploys a public S3 bucket, send a notification to this person, and in 5 minutes delete this S3 bucket. A bit, of course, harsh way, but it depends on your business needs, of course. And it's really a future-proof approach, apologies, because based on AWS config, you can build a lot of automation. And you can send notification to Slack, so you can basically publicly shame people who made the mistakes. But then, of course, I have security guys who come around. It's like, well, man, what about security? So what about security? We built a security dashboard, which is a big service spread between Amazon Search and Datadog, and we're collecting all metrics from services were interesting to understand if the service is up to our security standards. And then we push these metrics to Datadog, and what we're doing, first of all, we're creating these awesome dashboards that basically just on TV in office so people can see if red is bad and be aware and kind of, what the fuck, database with encryption is red, okay, let me take a look. Plus, these metrics are further propagated to PagerDuty attached to the service that basically has a security violation, and then developer know, okay, something wrong with my infrastructure, with my code, there is security vulnerability on dev, I have to fix it. And then we have a CISO policy. We basically don't have a CISO as such. We just spread this role between our engineers. So we have a on-call engineer, and then basically a bunch of very angry cloud engineers who are watching, so nobody will make mistakes. Just joking. We're not really shaming people, but we truly believe that everyone can make a mistake. Everyone can make slip. But next day, if there's a security incident, we have a post-mortem. We sit together and discuss, okay, how come that we have an unencrypted object? How come that our data lead to Datadog, for example, and what we're going to do to prevent this in future. And voila, as a developer, you're owning stateful infrastructure, you can deploy your own database. Of course, like when you're speaking about deploying databases in every infrastructure in AWS, it's important to understand how IAM roles is working. So IAM, it's essentially identity and access management, and AWS, how it's built. You have a bunch of accounts. This is sandbox account, nobody give a shit because it's a separate account for people to play with, and the only thing we're concerned is about price. But basically, everyone can assume a dev role in our IAM account, which is Jumpbox, and from this account, person could assume on production, on logging, on dev, on test, developer role. And what we're doing a really flat structure. So being a lead cloud engineer, being a lead developer, being the junior's front-end boy ever, we all have the same permission. Absolute admin on dev, read-only on test, read-only on acceptance, read-only with all forbidden client data on production. Very flat structure, very, help you to not doing clickety, help you to write CI/CD, because you cannot just go to test and create something there. But then, when production is going south, what to do? You can't already give everything to developers. They're creating infrastructure, they're writing code, they're doing CI/CD, and now production is broken, like it's fucked. What you have to do? You have to implement something about break glass rule. Well, before it was another, more smart, not so, my thoughts, how to empower developers and how ensure that basically people have access to production cloud engine and not a bottleneck. But essentially, it's not about that. This is a bit marketing. You already gave all knowledge and control to developers, and you're still not giving them access to production, which is weird. How you give developers access to production without being basically shooting your leg by your own mistake? you're doing it in the same way. Obviously. So this is what we're doing. Everyone can assume absolute admin role in production. Everyone. When person assuming this production admin access role, immediately created PagerDuty incident, and then sending all to cloud leads, to all basically kind of senior developers, cloud units, up to the CTO. And next day we have a basically mandatory post-mortem when we all sit together in a very secure room and we have a chat about, okay, why do we need to break glass on production? And basically trying to answer the question, was it necessary? And if it was necessary, this is your BN, your hero of the day. However, how we can ensure that next day, when it's happening again, we don't need to break this glass and everything is automated. And of course, by doing this, you're giving a great trust to your team, to your developers, and you explicitly tell to everyone that with great trust, the great responsibility will come. Everyone can assume production access. If you did it and you misuse it, we will know, we will find you, and door will be there and you will be fucking fired. And it's a very powerful message because people love to be trusted. And sometimes I'm having chats with very old school security guys and they're like, what if your front end or senior back end person will steal a client data? I'm like, and then what? If I can download all client data tomorrow, I will never do it because I will never find a job again in my life. I will go somewhere in, Indonesia, for example. From Indonesia, they will call my boss like, hey, how was Kirill? Yeah, he stole our data. Sorry, Kirill. No. That's developers are really aware about their responsibility, and no one cares more about security than good engineer. And now your developers are zoning permission elevation. They basically have admin access to production. And then there is one more small step that used to be kind of small version of proud owner of AWS. It's money. So you have your AWS budgets and you create a bunch of budgets per your account, and then you see somebody creating step function and running in a loop whole night before hitting a limit, and then cost is going like that, or something people making mistakes, these mistakes cost money. And people actually cost aware. They want to know, do I really need to run this huge database or just make a small, sexy DynamoDB and not have any problems? So you can create a budget. You give people permissions to create budget on AWS. Say hey, I need $300 or 10,000 millions for my service. And how you doing it? You're doing by tagging. You ask people to tag all their resources. And then in report, you can see that if one service costs 10,000 times more than another service, probably people doing something wrong. And people can create alarm on their service and receive a call when their budget is existing. So they can understand maybe it's misbehaving, maybe some kind of, payload is way too big, or maybe our service is way too popular. Well, it's all fine and all because we started doing it 3 months ago. And as you can see, the most popular services no tag. It's because we didn't tag our services for 2.5 years.
What's the green one?
It's the top one, the green one. I'm not 100% sure, but I believe it's Canadian. I don't know. So basically, color, it's a service one. So this is not AWS service. This is service like business services. And this is a screenshot from AWS console. It has a limitation, so you have 5 most expensive services and a huge XML down with all your services. So basically, if you're not on the top 5 most expensive servers, your name is not going to be there. I think that green one is our identity service, which basically we have a storage of all our clients. And every time when one microservice invoke other microservices, is going through identity service to propagate the ID of the client from one service to another to ensure that on this service client could only access certain data. So it's actually heavily involved service, and it's not the cheapest one. But yeah, the most expensive, no tax, so way to go. So yeah, and at the end of the day, your developer team is owning budgets. Well, that's basically it. Then basically they fire you and they send you to have an awesome presentation meetups because that's what you're doing. If you have some questions, just like I will be happy to answer them. If you want to ask me questions like what the hell and how you can give developers access to production, which is a stupid idea from many people's point of view, you can find my articles on Medium, and you can find me in LinkedIn, and you can just spam me in my Gmail account with questions. Thank you very much, and I hope you learned something. Sure.
So you were talking about choices of technology, specifically like CloudFormation and then Terraform. And so like it went so like during your talk that you chose serverless framework that's when you deploy to AWS actually uses CloudFormation. But after that you went into building a script in Terraform to trigger serverless, which is like basically being your own uncle in a sense. So like what happened there? Can you like
the bad talking on presentation happened, so the story probably was not so straightforward and clear.
Yeah,
so
fine.
I will elaborate a bit more. On the very beginning, we made a choice with which framework we're going to deploy our infrastructure. Nobody even thought that developers are going to touch infrastructure, because how come? And we was choosing between Terraform and CloudFormation. And for certain reasons that I can basically disclose to you, we choose Terraform because from our point of view, for our type of commented Terraform for deploying from cloud engineers are better. But then we're like, okay, but then developers want to deploy. And it's a completely different story because it should be more abstract, maybe not so, I don't want to say complicated, right? But not so deep and not so frustrating sometimes. No, it's a separate zone of experience. So you want to find something developer friendly. And you're like, okay, are we going to ask people to do Terraform? No. Definitely don't want to do CloudFormation because there is no one in company who will teach developer how to do CloudFormation because we didn't know back then. And then you have a choice between serverless.com and SAML, and you choose serverless.com because, of course, serverless.com is using CloudFormation under the hood. But you don't need to know anything about CloudFormation. You have a YAML file, you press a button, it generates CloudFormation template, push it as a stack. Stack is deploying. For developers, it's like transparent. Sometimes it's happening, for example, when you did something really wrong, you stack, kind of stack.
It needs time because when you delete one stack and you start another and you restart. That's like in my experience.
Yeah, or for example, you have a stack and then somebody manually adds something, which is not possible anymore, but was possible back then. So when like serverless.com is using CloudFormation below it, but it's like driving a car. You know, if you're driving like me, I don't know the difference between diesel and gasoline, just like fucking driving.
Yeah.
Huh?
Yeah, hi. Thanks for the good presentation and very entertaining as well, because there were a lot of technical words and you could explain with a lot of simplicity and curiosity. Question. So when you say you're already into the production, so your company Newton is already lending loan, and when you allow your developers to access production, have you experienced any bad fallback from that experience, or everything went very well?
Well, the question was basically we're already running a production, and we have developers accessing production. Are we still running on production or we all fired? No, basically company ran, I think, came live, like publicly live in September 2017. So right now we have about 1,700 clients, which doesn't sound a lot, so we don't have a lot of problems with load, but it's 1,700 companies, so it's quite a success. Well, not according to me, but according to the stakeholders from the bank, so I trust them. No, we don't have any drawbacks of developer accessing production. AWS has a service called CloudTrail, which is giving you all API calls recorded in a very detailed way, and they ship to another account from there they serve. So every time a developer, which is not happening a lot, usually it's like once per 2 weeks or one per month, when somebody broke a glass, you have a detailed log per second. Broke a glass, came to this S3 bucket, opened that file, changed this line, closed the file, logged out. And of course, like, well, no, we didn't have it in Dropbox. What we have sometimes on the very beginning, that to ensure that people are not building processes when they have access to acceptance and then not have access to production, and this is too late to recognize mistake, we did basically, like, people don't have access to test. So they have to break glass first on test, realize they're doing something wrong, so they have to automate it, so they already kind of shoot their leg on test. And then it was some, problems with accepting it, because like, how come I always had access to test and now I don't have it anymore? Okay, you have to accept it on test, because you will face this problem in production for sure.
And more related to business, so this company is running independently, or it's integrated with ABN AMRO in terms of offering?
Basically, New10 is operating under ABN AMRO bank license, so we have to be compliant with all ABN AMRO policies. But we're running independently in terms of infrastructure, code base. The only thing that we share knowledge, right? I'm sitting with the CXO guys and the engineers to understand that we're all on the same page. But the only point of technical iteration, we're delivering our data and our logs and our reporting to the bank because it's a regulatory requirement.
Yeah.
Yes. You gave all of this access to your developers. I can imagine there's an amount of developers that then think, well, this is really cool, I can do my job better. Did you have any developers that got scared or showed any resistance to getting this level of access and having that level of responsibility?
Yes. So on the very beginning, well, first of all, New10 is a really luxury position of greenfields. So from the very beginning, we have this horrible motto: no bloody juniors. Well, I'm just over-exaggerating, but it's like hiring only very senior people because we have to bring servers to production very fast. Then, of course, we start having more junior, more medium interns, and of course, those people are not scared; they're more conscious. So what I can see, because all breaking glass, or escalations coming through me, I can see like, hello, my name is Bob, I have 15 years, this is like why I broke glass, so hold your pants, gonna do something on production. Dude. Like, hello, my name is Anne, I am our intern, I discussed it with that person, they told me to break glass in production, and then that's what I'm gonna do, this is my plan, do you think it's alright? Like, yes, please do it, do it now. So we really encourage people to learn, to make mistakes if they're learning from these mistakes. Yeah, but less senior people are more conscious, but we never had a person who say like, fuck no, I'm leaving the company. Well, I think that's the end. We can go home and drink some beer. Oh, sorry.
Now that you moved all responsibilities to developers, what's going on with your job then?
Well, I'm standing here in front of you. No. So we have 3 layers. So we have conception of tier 1, tier 2, and tier 3. Tier 1 is essentially VPC, CloudFront, low level from account all to VPC, part of the AWS, which is responsibility of me and my team. We have something called tier 2. It's a services, independent services, which we are running, but they're not bringing any value to client. Security dashboard, some metric collection, some internal tooling, which we are responsible for as well, but they're not facing clients. And we have a tier 3, it's where developers running their cool stuff. Plus, well, it's like, it's not only giving responsibility, it's helping. It's not about saying, now it's your problem. It's like, now you're responsible, let me help you. All the Terraform model has to be designed, written, and then updated by cloud engineers. So we're helping them. Well, I think this is the end. Thank you a lot again.